Next up for lesson 8.2 day 2, we're going to talk about dividing rational expressions. So first we're going to multiply by the reciprocal, then we will factor if possible and simplify. So really this is a lot similar to just multiplying rational expressions. We're just adding that one step where we need to multiply by the reciprocal. So to refresh your memories on this, we've got 1/2 divided by 2/3. So we would take our first fraction and leave it the same. Then we switch multiplication to division, and then we flip the second fraction because that is the reciprocal. So it would become 3/2. Now we just multiply the top, 1 times 3, and then multiply the bottom, 2 times 2. So our answer is 3/4. So now let's apply that to our rational expressions. So our directions say to divide and assume that all expressions are defined. So again, whenever you see this, assume that all expressions are defined. You do not need to say what x cannot equal to. So don't worry about that part if you don't have to. So starting with number 6, we have 5x to the 4th divided by 8x to the 2nd, y to the 2nd, divided by 15 over 8y to the 5th. So our very first step is to change it to multiplication by the reciprocal. So we have 5x to the 4th over 8x to the 2nd, y to the 2nd. That first fraction just stays the same. We change division to multiplication, and then we flip our second fraction. So we have 8y to the 5th over 15. Now we're going to simplify what we can. I can see that I have a 5 in the numerator and a 15 in the denominator. So I can divide both of those by 5. That gives me a 1 and a 3. I also see that I have an 8 in the numerator and an 8 in the denominator. So those cancel out and leave us with just 1s. Then we've got x to the 4th in the numerator and x to the 2nd in the denominator. So we can subtract our exponents, 4 minus 2, and that leaves us with x to the 2nd in the numerator. And then lastly, we have y to the 5th in the numerator and y to the 2nd in the denominator. So we can subtract those as well. 5 minus 2 leaves us with y to the 3rd in the numerator. So now we're just going to multiply the top. We've got 1 times 1, which is 1, and then x squared times y to the 3rd. Then in the denominator, we've just got 1 times 3, which is 3. So our final answer is x squared y to the 3rd over 3. Okay, now let's give number 7 a try. So first we're going to follow that same first step where we switch it to multiplication by the reciprocal. So 2x to the 2nd minus 7x minus 4 over x squared minus 9. That first fraction just stays the same. We change division to multiplication and we flip the second fraction. 8x squared minus 28x plus 12 over 4x squared minus 1. Next, let's see if we can factor it all. So starting with our numerator of our first fraction, I'm going to see if I can factor that into two binomials. So I'm going to start with 2x times x. Then I'm going to take a look at the factors of 4. Feel free to use the AC method if you prefer that. Otherwise, if you want to guess and check, you can do that as well. So the factors of 4 are 1 and 4 or 2 and 2. So I'm going to try 1 and 4 first. And this would give me a 1x and an 8x. And I'm trying to get these to add up to my middle term, which was a negative 7x. And I can do that with an 8 and a 1. I would need my 8x to be negative and my 1x to be positive. So if that doesn't work on your first try, just make sure you keep checking until you get the correct answer. Now on the denominator of my first fraction, we've got x squared minus 9. That is a difference of perfect squares. So we can factor that into two binomials. We take the square root of the first term, which is x, the square root of the last term, which is 3, and then we have 1 plus, 1 minus. Now moving on to our second fraction. In the numerator, I have some bigger numbers that I'm working with. So I'm going to see if there's a GCF that I can factor out. And it turns out I can factor out a 4 of all three terms. So I'm just dividing each term by 4, which gives me 2x squared minus 7x plus 3. Then in the denominator, we've got 4x squared minus 1. So that is also a difference of perfect squares, just like x squared minus 9. So we take the square root of the first term. The square root of 4 is 2, and the square root of x squared is x. So that gives us 2x. And then the square root of our last term, or 1, would just be 1. Then we have 1 plus, 1 minus. Now before I start simplifying, I'm going to take one more look at the numerator of my second fraction. So I did factor out a 4, but I think I can factor this trinomial one step further. So I'm just going to write a note down below. We've got 2x squared minus 7x plus 3. So let's try and factor that. We have 2x and x, and then the factors of 3 are 1 and 3. So we just have to figure out where those would go. This way would give us 1x and 6x. So I have to ask myself, could that get me to a negative 7x? And yes, it could. I would just need to make sure that both of these signs are negative, and that would be factored. So I'm going to go back up here and just change this part so it is completely factored. We have 2x minus 1 times x minus 3, and make sure you leave that 4 in front. Okay, now that everything is factored, we can start simplifying. So I see that I have a 2x minus 1 in the numerator and the denominator, so those can cancel. I've also got 2x plus 1 in the numerator and denominator. And we've got x minus 3 and x minus 3. Next, I'm going to multiply the top, so we have 4 times x minus 4. If you want to distribute that, you can, but you do not need to. And then in the denominator, we have x plus 3. So our final answer is 4 times x minus 4 over